Hey, this is Hunting for Privesc and Windows Applications, and I'm Kenton McDaniel. A little bit about me: I love hacking things, I love cracking passwords, and I like Privesc a lot. It's one of my favorite subjects. So the idea of privilege escalation is gaining privileges from lower set to a higher set. And specifically, for this presentation, I want to talk about going from a standard user privilege to the NT authority system user in a Windows environment, and hunting for ways to elevate your privileges through Windows applications. If we want to gain the privileges of a user, if we can gain the privileges of a user that has extended rights, like SE impersonate, or we gain the privileges of an administrator, then we can become NT system with a trivial amount of effort. So our goal should be either to gain the rights or tokens of that user, or just go straight to NT system from standard user. So I'm not going to drop any 0 days. I'm not going to be going deep into anything crazy. I'm not going to be talking about reverse engineering or binary exploitation. I'm just going to present my methodology for how to look for common privilege escalation vectors in Windows software that's normally installed on machines. So the first thing we want to do is we want to build a setup. We want to identify the software that we want to hunt in, and then we want to legally obtain a copy of that software. And then once we've legally obtained a copy of the software, we want to set up a VM with the proper tools installed so that we can look for that privilege escalation, so we can hunt inside of that VM. We don't want to hunt in a live environment. Hunting in a live environment leads to a lot of unintended behavior, because a lot of what we're going to be talking about is interrupting the regular flow of the application, interrupting regular calls of the application, doing things that will break application logic. And so hunting in a live environment means that we're going to be breaking functionality, and if it's a network-connected application, we could be breaking functionality for other users. So you always want to isolate your own VM, set it up just to hunt for your Privesc in that software. Lots of applications will make use of Windows services. These are prime targets for privilege escalation. So they'll set up Windows services as backing services to provide functionality for the application so that they're always on and always running. These are our prime targets because they're usually running with elevated privileges. So when I go through the different things to look for, the different use cases and considerations, always start with Windows services if you can find a Windows service, and then you can trickle down to normal applications after the fact. So out on my GitHub, just github.com, Kenton McDaniel, there's a vulnerable service repo, and inside of that repo, I've just got some code snippets that are very contrived, but they are showing examples of privilege escalations that I've found a lot. And so one of the fun things that I like to do is I like to hunt for CVEs. If you're not familiar with a CVE, it's common vulnerability is exposure. So you go out and you say, hey, I found this vulnerability in the software. It gets listed in the CVE database. I love to go hunt for CVEs and random stuff. And so these are different things that I've found across all kinds of different software running on Windows. I want to say I'm up to 30 CVEs or so for Windows applications, something like that. So they're pretty common, and these happen a lot. So lots of developers make a lot of common mistakes and assumptions when they're writing their software of how to handle inter-process communication, how to handle calling into other processes, how to handle calling into dependencies. They assume that the underlying file system won't change. So they assume that if a file is there, it's always going to be there. They assume that they can call down into user land whenever they want to call down into user land. And the definition of user land is anywhere that a standard user can modify or update. So I don't consider the read permission a standard user land thing, because usually read doesn't get me anywhere. So they'll make these assumptions that they can just call down into user land whenever they want to, but they don't understand the ramifications of calling down into userland. Same thing with third parties, right? So they're calling their own stuff in userland, or they're calling third-party stuff in userland. Or they'll let Windows handle the path navigation for them. And I'll dig a little bit deeper into that. They'll just say, hey, Windows, I want to run whatever binary, whether it's a DLL, exe, I want to run it. And they'll let Windows figure out where it is. And that can lead to a lot of privilege escalation as well. So we're going to talk about two useful tools. The first one is PROCMON, or Process Monitor. PROCMON is the old one. That's just what I call it, even though it's now Process Monitor. And iCackles. So with these two tools, unless somebody's already picked over that application, you're pretty much going to find a privilege escalation or an unintended disclosure of information in most Windows software, because most developers don't even think about these things. And most applications never undergo this kind of review. So all you need is Process Monitor and iCackles. So what Process Monitor is it allows you to profile what an application does during its running state, or a Windows service does during a running state. It's a debugging tool. So you attach to a process, it'll show you everything that's going on the file system, other processes that are being created, and registry keys that are being searched. So this shows you what an application is doing. And before I said we wouldn't get into reverse engineering, it's much easier to just watch the application and see what the application is doing. If we profile it with Process Monitor, then we know the application is making calls out to these places, the application's loading things from these places, and then we can use that with iCackles. So we can use it with iCackles to look at permissions. Do we have permissions to write where the process is calling to? Do we have permissions to write to registry keys the process is reading from? And then this can often be like a layered approach. Think of like an onion, peeling back the layers, right? Maybe it'll make a call to another process, and then we attach to that second process and watch down. So we could be going 2-3 layers deep in the process tree to figure out which one of them is calling something in user land that we can either inject into, that we can replace. So you start painting a picture of what the application does and who its dependencies are, and that allows you to be able to move forward with your privilege escalation. And if you guys have questions during, I maybe have a little bit, I'm going to rush through this, but we probably have time at the end. But if you have questions during, raise your hand. Lights are super bright, so yell at me. If you have a question, yeah. Yes, I will make the slides available afterward. That was the question. Okay, so once we figure out where we have the permissions, then we're going to talk about the high-level concept of proper binary validation. Almost nobody does this that I've seen. Some people do it, but almost nobody does proper validation of binaries. And what I mean by that is, for example, if I'm going to make a call from executable A to executable B, do I first inspect executable B to make sure that it is, number one, signed with a code signing certificate, number two, the certificate is valid, and for the issuer that I expect, and number three, does it have a good MD5 sum, right, or a SHA-1 sum? So almost nobody does this. So if we find a place where we can overwrite that executable, almost nobody's checking to make sure it's the right one. So you can just drop whatever you want in there, intercept the call, and turn that into a privilege escalation because nobody does proper validation. And why don't they do proper validation? It's costly. It affects performance of the application, and performance is king these days, right? Nobody wants a poorly performing application. Nobody wants to have that slow application that an end user can't stand to use because it's so slow. So you sacrifice your security for your performance. And this is a big one. If we could implement certificate validation and chain checking throughout the entire length, then we have to start getting into reverse engineering to find other things. But because almost nobody does this, you can find these very surface level privilege escalations very trivially. So ELECTRON is a great use case for this. Anybody familiar with ELECTRON? Anyone? There's some hands out there. So ELECTRON, I'm not going to dig into it super deep, but ELECTRON is a framework to help you develop and deploy applications cross-platform. Pretty much every single ELECTRON app in Windows has a DLL hijack that is valid for it to this day. And that DLL hijack most of the times won't result in privilege escalation because of where it's trying to load the DLLs from. Usually it's from the app data folder of the currently running user. And so you can maybe get persistence there, but you're not going to get a privilege escalation. But this is just an industry-wide use case for nobody's doing things the right way, right? They're trying to load binaries that should belong in the Windows folder, but instead they're just saying, hey, Microsoft, you figure it out, right? I want to call this thing. And Microsoft's like, great, I'm going to try it first where you are in your current directory, then I'll go to Windows. And if you're in the current directory, just drop whatever.exe that ELECTRON app is looking for, and it'll load it up and run it. So it's these simple patterns and processes that nobody does that we can take advantage of. So again, talking about arbitrary execution of executables without verification. So you can go multiple hops down. Don't stop at the first hop. Keep going, right? Go and see, okay, if I call executable number 1, does executable number 1 load any DLLs? Does it call any other executables? So start hopping down the process chain to figure out all the different places that things are being called. Once you find all those different places, fire up process monitor, attach to one individually, do normal user activity, let it run, and see what it's calling out to. And then you can follow down the chain. So the verification has to happen at every step, otherwise you can interject yourself into the process. It's great for us because it's super easy to track. If you're calling external EXEs from your application, it's super easy to find. Just filter down in process monitor and you'll find it in 5 minutes. So this is a very contrived code sample. This is what's out on my GitHub. And I'm gonna try to read it here. So we're just looking to see if a file exists in a location, right? And if that file exists in a location, just call process.start. The other stuff on it is for a CTF that I made. So that's me generating flags for the CTF so that the players of the CTF can get the flag to prove they did said challenge. But the real thing is at the bottom, right? Just call process.start. Now, we're not doing anything to check and make sure that the file in that location hasn't changed from what we expect. We're not doing anything to make sure that it's the right file or the file that we want to call. We're just calling it. And this is a very common thing in Windows applications, incredibly common. Just fire up a process. Don't validate anything about it, just fire it up. So another thing to look for, arbitrary loads of DLLs, right? A lot of people think about loading up other EXEs, also DLLs. If you have a dependency library that you're loading at runtime, let's say you're doing some runtime some runtime injection or some runtime reflection, you're loading up these DLLs. Is the proper signature being validated? Most of the time, no. So you can put your own DLL into that space, hijack the call that they're looking for, and this goes a little bit beyond process monitor. You have to do some other things, and I'll leave that up to you guys. But if this DLL is being called, then you can just put your own DLL there and intercept the call and take over the process chain and get privilege escalation. And same thing, goes layers deep, right? Don't just stop at the first one. Profile everything all the way down. See what's being called where. So this, again, is a very contrived example. And I'm using run DLL 32. This is purely for ease of use so that I can get this CTF to run on everyone's machine. But look for dynamically loading instances of DLLs. Right? Anytime it's dynamically referencing or loading an instance of a DLL, if you can intercept or control that call, you might be able to achieve privilege escalation depending on the permission set of the caller. So registry keys is another thing to look for. Calls to read and write registry keys that are not well protected. Applications love to store stuff in the registry. They love to store locations for other applications in the registry. And most of the time, those are not well protected. They're not read protected or write protected. So if you can figure out where if an application is loading up its dependencies through the registry, then again, you fall back to our friend iCackles to say, okay, it's loading up from this path. What are my rights on this path? If there's anything in that path that's loading other things, right? And here we go down the chain again. So look, it's loading something from the registry. Great. What is it doing with what it's loading from the registry? Is that how it's handling where it loads its dependencies? Is that how it's handling where it makes child process calls? Those are the kind of things you can look for and say, okay, great. Are any of these registry keys weakly protected? Can I write to them? Can I create subkeys? What if I can create a subkey that the application might want, but I don't know is there? Start creating subkeys. See if it tries to read from them. Right? So look at kind of the structure of how the registry is laid out for this application. Start creating subkeys. If it tries to read from them, you know you're on the right path. So you just look at the performance of the application, what it's doing, and you'll know. And this is, again, our other contrived code example, where we're just reading the path to execute from the registry. And this is very, very common. This is not uncommon. Just read up from the registry where I'm supposed to execute from. I'm moving around a lot. Am I still? I'm good. Okay, sorry. I'm a hands talker and I move, so I just want to make sure I was still in the camera. So yeah, so look and see, okay, again, can I read? Can I write? Read is good because it allows us to maybe debug and look for other things. If I can write to the registry, then I can probably intercept what they're doing and I can probably get privilege escalation depending on the permission set of the calling process. So registry keys that relate to the application. So don't just focus on registry keys used solely by the application, but also registry keys that are related to the application. And this could be Windows Service Registry keys. So I didn't even dig into looking for weakly protected Windows services, right? That's another common thing. I didn't dig into that, but look at all the registry keys that support the service or executable and its dependencies. Because most people just expect their dependencies to be fine. And the reality of it is, most of the time, you can control a lot of those dependencies. So now I want to talk about hard-coded or weakly protected config files. So a lot of applications use config files, right? So inside of those config files, we can glean information that can help us with our privilege escalation. So what if inside of those config files there's a password? Password reuse is a huge thing, right? So if there's a password inside of there, maybe I can just use the password. Maybe I'm done. Maybe I already got the admin password. So look at these config files. It'll also tell you more about the behavior of the application. So inside of here, I give a special shout out to the DP API. Is anyone familiar with the DP API? So the Windows DP API is Windows' the best and interesting effort. Let's say that it's an interesting effort by Microsoft to allow you to protect your secrets. The thing is, anyone on the machine with the same privilege set or same username as the one who protected the secrets can also unprotect the secrets. So if you see weakly protected secrets using the DP API, you can start targeting that user who you know you can go and unprotect the secrets from. So look for blobs of data that are base 64 encoded in config files. If you base 64 decode them and it looks like a random blob of data, it's likely protected by the Windows DP API. And so when you decode that, you see this just random data, you're like, okay, that's likely DP API data. I need to try to unprotect that with the credentials that I have. And if you can unprotect it with the credentials that you have, then you have actionable information to move forward with your privilege escalation. So look for the config files, right? And that's another thing Process Monitor will help you do, is it'll show you files that are loaded. So it's going to load up your config file at start time, and that'll give you a wealth of information that you need. So relative paths or incomplete paths. So I talked a little bit about this, but let's dig into it. So if the application makes a call to a binary and lets Windows figure out the path, then you can hopefully inject yourself somewhere in that path. The Windows search path, I don't know that it's changed in a long time. I didn't look to see if it's changed. I know it's been the same from XP all the way through 10, that it's always going to start in the location of the running application. So if we can write to the location of the running application or somewhere in the call tree that Windows will follow, then we can inject ourselves into the process. So, and bonus points, if someone else has modified the path variable inside of Windows, and we can write inside of there, Windows will change its search order based on the path variable. So if we look at the path variable and someone's put themselves in there and they're before the Windows folder, can we write to there? Can we achieve privilege escalation through somebody else who may not even be vulnerable having manipulated the path? I've done this a couple times. You're on a machine, you find out the path's been modified, and you can write to there. Nothing in there is vulnerable to privilege escalation, but you can drop other binaries that other services are looking for into that path, and they'll get called first. So you can have these vulnerabilities are created by other software packages inserting themselves into the path. So check out the path, because Windows will always follow the same path when it's loading things. So if you found something following this methodology, then you have to build a working proof of concept. Because if you don't have a proof of concept, you don't have a privilege escalation, right? Theory's great, but if you don't have a working proof of concept, you've got nothing. So you need to build your proof of concept that will elevate your privileges and restore proper application flow. So that's the biggest thing, right? If we're going to use this privilege escalation in the context of we're going to say that we're doing this the right way, right? We're elevating our privileges as part of a penetration test or a red team engagement that we're doing. We need to restore the application flow so that we're, number one, not detected, and number two, successful in our privilege escalation. So this is where a lot of the real heavy lifting comes in. So in our sandbox, we identified it. Now we need to craft our privilege escalation that elevates our privs and restores the flow. And this is complex. And a lot of the times you can't restore the flow. So you have to be careful about when you choose to use and not to use your privilege escalation vectors. Now is the time to find source code if you can get it. Put your source code reading skills to use. Find that source code, dig through, see what you can fix in the path, see what you can find in this privilege escalation path to help you craft a working POC that doesn't break the software. Because it's important to be as stealthy as we can. We want to remain undetected for as long as we can. Don't leave any artifacts and traces. The disk is lava, right? Don't touch disk if you don't have to. Never touch disk. Always be in memory. If you have to touch disk, clean up after yourself. And then restore the state of the machine back to how it was before. Then your POC is something that you can weaponize and use throughout your engagements. And that's all I have. Does anyone have any questions? Yeah.
From a blue team perspective on this, what's the best way we could defend against this? Is there a way of locking the path variable, or is there a way that you could look for this with file integrity checking or anything like that?
So the best thing to do is to ask your vendors if they've had an application security test done and what the results of the application security test were and what their remediation plans are. So if you have software that's deployed throughout your environment, you want to go back to the vendor and say, when's the last time you had an application security test? What were the findings, right? How many of those findings have been remediated? You can lock the path down. It should be locked down to administrators only. So that's a good thing. But you hope that other software packages don't modify the path, right? And a lot of the stuff that I'm talking about is going to be kind of hard to detect, depending on how good you are at weaponizing it. So the best thing is to everyone go to your vendor and say, when's the last time you had an application security test? What were the results? What's the remediation? And then ask them, because we're talking about Windows software here that's maybe client server, maybe just running on this machine. So it's going to be a little bit different than a web app test. Say, do your testers know how to do Windows client server stuff? Because it's a different mindset. It really is. It's a different mindset than web app stuff. But that's a great question. Thank you. Does anyone have any other questions? All right, thanks, guys.